Very good morning, children. In the last video, we learned about concepts that are related to chemical equilibrium. Our chapter equilibrium is mainly divided into two parts. One is called chemical equilibrium. There we learn the topics like Kc, equilibrium constant related to the concentration term, and also Kp, equilibrium constant related to pressure term. Means there the reactants may be the liquids or solids, or the reactants may be the gaseous phase. But now presently we are under the second level of this chapter, that is called ionic equilibrium. Can you just imagine at your home you will be preparing some salt solution. Means what? You will take some salt and you will dissolve into water. For that you will add some nimbu pani or some sugar, then you will make a sugar syrup, which is nothing but the vitamin C solution we can call. Here whenever we are dissolving we are adding the salt into water. This salt will dissociate into ions. Means that it will break down into sodium ion and the chloride ion. How do salt will dissociate, children? Salt will dissociate as sodium ion and the chloride ion. There is no place to introduce here, so I am taking my rough work here at the last. Sodium chloride, that is the solid, when dissolved in the liquid water, it will dissociate into sodium ion aqueous ions and the chloride ion aqueous ions. Means what? It was dissociated. Salt was dissociated into cation and the anion. So the substance that was dissociate, after dissolving into water, it is forming some ions. And now you can see these ions will move from one place to another. And these will conduct electricity. Which will conduct electricity? The conductance will be increasing. The presence of these cations and anions will increase the conductance. But you see the same thing with sugar. You cannot see the sugar when dissolved in water to dissociate into ions. It is just mixing in water. And it does not conduct electricity or does not increase the conductance of the electricity. So here there are two main points to define the compounds that are present around us. Now coming to the point, the present topic is when we dissolve substance in water, it is dissociating into ions, and the presence of these ions is increasing the conductance. So these kind of substances we are calling as the ionic substances. What do we call as the ionic substances? And there is an equilibrium. With these ions from the non-dissolved electrolyte. Such kind of equilibrium we are calling as an ionic equilibrium. What are we calling as an ionic equilibrium? So let's go for the definition here. What is meant by the ionic equilibrium? The equilibrium involving ions in aqueous solutions. Once again, the equilibrium involving ions in aqueous solutions is called as ionic equilibrium. For the best example we can take sodium chloride and water. We can take not only sodium chloride. You can take either some citric acid that is taken from the lemon juice, or ascorbic acid that is taken from the orange juice. Right, these all are organic acids. What are all they? Organic acids. And you can also see one more clarification here. My clarification here is this sodium chloride when dissolved in water, it will completely dissociate into ions. Whereas, do you know the noodles what we prepare as snacks? In that they will prepare, when they are preparing, they will be adding the acetic acid or the vinegar. Vinegar is an organic acid. CH3COOH is the formula. This is already a liquid. When you dissolve in the water liquid, its dissociation is very less. What is this dissociation, children? Its dissociation, it is releasing very less less number of H plus ions. Here there is no complete. It does not completely dissociate into ions. Which one is not completely dissociating into ions? Acetic acid is not completely dissociating into ions. But sodium chloride when dissolved in water, it is completely dissociating into ions. So again now our electrolytes are further divided into two types. Strong electrolyte and the weak electrolyte. So before we go to the concept, first let us see here what interaction we brought for ionic equilibrium. After that we need to introduce what is meant by electrolyte and what is meant by non-electrolyte. I brought one example for you, that is with sodium chloride. What is the example? The substance that dissociates into ions when dissolved in water is called as an electrolyte. Sodium chloride with sugar. The sugar is not dissociating into ions. So the substance that does not dissociate into ions when dissolved in water is called as an non-electrolyte. So let us give the definitions here. Electrolyte means what? Compound that conducts electricity in aqueous solutions by dissociating into ions is called as an electrolyte. Especially what is their main property? They conduct electricity. What is the example we can take? Can you take the example as our simple sodium chloride? Yeah, this is the salt children. What is this one? Salt. Or even the solution of HCl can also conduct electricity. This is an acid. Then how about our sugar solution? Sugar solution is not conducting electricity. Means what? It is called as a non-electrolyte. So compounds that does not conduct electricity but in their solution state were called as a non-electrolyte. Example what we are able to give? We can use sugar as the example. Now we are concentrating much about our topic called electrolytes. Again now we are classifying these electrolytes majorly into two kinds. Already we started like sodium chloride completely dissociates into ions, whereas sugar does not, acetic acid does not dissociate into ions, completely into ions. So based on that property we are dividing our electrolytes into two types. Strong electrolytes and the weak electrolytes. What are they? Strong electrolytes and the weak electrolytes. So let us see the definition. Electrolytes in which dissociation proceeds to almost completion. Electrolytes in which dissociation proceeds to almost completion. Means whatever substance is there in the solid form, if you dissolve it into water, it will completely dissociate into ions. So such kind of substance we are calling as strong electrolyte. Many examples we can take. We can take from the salts. What is the salt? The salt is formed by neutral substance. So salts like sodium chloride, potassium chloride or magnesium sulfate you can take. Or you can take the substance like acids. There are HCl, H2SO4, HNO3. These are all called very strong acids, right? And the bases also we know, sodium hydroxide, potassium hydroxide. So our substance means the electrolyte. It may be a salt, or it may be an acid, or it may be a base. So now we are bringing again the point in our difference, like our electrolytes are further classified into two types: strong electrolytes and the weak electrolytes. We already know. Are we using any sulfuric acid in our food preparations or nitric acid? No, but we are using the lemon juice and we are using the citric acid formula containing compounds. Even the curd, when it single formula contains the it is also having an organic acid, right? So these are all weak acids. The acids that are present in our food material that we are taking regularly, they contain the weak acids. Means they are weak electrolyte. Their dissociation is not complete. So what we are bringing is our electrolytes are made up of three compounds: salts, acids and bases. But these salts are not divided into strong salts and weak salts. Only the acids and bases are separated into two types. They are strong acids and strong bases, weak acids and weak bases. What is the concept? Strong acids and the strong bases, as well as weak acids and the weak bases. We have already introduced about the acids that are under strong electrolytes. These are all mineral acids. These kind of acids, children, these are all mineral acids. Generally, weak acids are organic acids. Weak acids are organic acids. Weak acids are organic acids. One of the examples is the carbonic acid, H2CO3. Another example is the acetic acid. How about the bases, weak bases? We can see this basis does not dissociate completely into ions like aluminum hydroxide or ammonium hydroxide or calcium hydroxide. So presently let's go well in define what is meant by an acid and what is meant by a base. We already know about salt. What is salt? The salt is the neutral substance that is formed when an acid is reacted by a base. So we are not defining much with the acid, salt. We are now defining much with the acid and the base. Many scientists have given their explanation, so we will go individually with all the scientists who explain about these acids and bases. Note on this point, student. Yeah, let us see here about the acids, bases and salts. Actually, there are three scientists that though they had explained about the acids, bases and salts. Three concepts are there, different concepts. One concept is called about Arrhenius explanation. Arrhenius explanation, how he explained about the word acid and base. One more scientist is called Bronsted. Along with him he is having one more scientist called Lowry. Their explanation we will see. And Lewis is the one he explained in another way. So these are the three different kinds of words of explanations that we are saying regarding the term acid and base. So let us start our explanation using the Arrhenius concept first. What according to Arrhenius is an acid or a base? We know generally, in the 10th standard also we learn, generally acids are the substances that will produce H plus ions and bases are the produced that will produce OH minus ions when they are dissolved in water. Is it not? What do the acids will produce, children? Acids will produce H plus ions when they are dissolved in water and bases are the substances that will produce OH minus ions when they are dissolved in water. So let us see here, according to Arrhenius concept, an acid is a substance that produces H plus ions in aqueous solutions when they are dissolved in water. Like HCl, so that is a gaseous substance. When you dissolve that in water, the water state is a liquid state here. The little water state of the water state will be a liquid state. The HCl will produce H plus aqueous ions. Means what? Generally this H2O is there, right? The H2O, we are writing in this method. H2O. That will have two lone pairs of electrons. The H plus is actually generated. It will be receiving electrons from the water molecule and that will form H3O plus aqueous. So it may be noted that acids are the substances that will produce H plus ions, or we can write they produce the hydronium ion. What do they produce? The hydronium ion. H3O plus is called as the hydronium ion. So acids, if you take nitric acid, which is a liquid, when dissolved in water, it is forming H plus ions and then O3 minus aqueous ions. So the substances that are producing H plus ions when dissolved in water are called as the acids according to Arrhenius. But what is a base according to Arrhenius? According to Arrhenius, the base is a substance that will produce OH minus ion when dissolved in water. OH minus ion when dissolved in water. So NaOH you can take sodium hydroxide when dissolved in water, it is forming Na plus aqueous ions and the OH minus aqueous ions. As well as potassium hydroxide, which is a solid when dissolved in water, it is producing K plus ions, aqueous ions and the OH minus aqueous ions. So substances that are producing OH minus ions when they are dissolved in water are called as the bases, and substances that produce H plus ions or HMO3 plus when dissolved in their aqueous solution is called as an acid. So note down these concepts about the Arrhenius theory. So let us see, children, here about our the next science is our next scientist here? Our next scientist is Bronsted and Lowry. Yes, these two are different scientists. They explained about the acids and bases in their turn. According to our concept, Arrhenius. What did Arrhenius explain? Arrhenius explained acid is substance that gives H plus ion and base is substance that gives OH minus ion. But according to Bronsted and Lowry, they are saying acid is a substance that can capable to give H plus ion. So acid is a substance that is capable to give H plus ion, whereas the base is a substance that is capable to accept the H plus ion. That is the only difference between the concept explained by Bronsted and Lowry. Once again, I am repeating. Bronsted and Lowry explained acid is a substance that can donate H plus ion, whereas the base is a substance that can accept H plus ion. Very simple terminology. But let us here see some differences here. Let us say we know HCl. HCl on dissociating it will produce H plus ion and the Cl minus ion. And we know acetic acid also. Acetic acid dissociates to give CH3COO minus and also H plus ion. So it is producing H plus ion, HCl is producing H plus ion, whereas acetic acid is also producing CH3COO minus as well as H plus ion. So the substance that produces H plus ion on dissociating in aqueous solution we call as an acid. But along with the H plus ion, there are some counter negative ions. In case of HCl, what is the counter negative ion? We form Cl minus. Now there is a new word to define this negatively charged ion produced from the acid after dissociating into ions. It is called as its conjugated base. Once again I am repeating. The negative ion formed when the acid on dissociation, it is formed as the conjugated base of that acid. So if you see HCl after dissociating into ions will produce HCl and the Cl minus ion. Now I am calling the Cl minus as the conjugated base of HCl that is produced from the HCl. If you take from acetic acid, CH3COO minus, which is a negatively charged ion, we call as a conjugated base of the acetic acid. So a new word is there, the negatively charged particle that is produced by the acid on dissociation. We call it as the conjugated base. Now can you once again define what is known as this conjugated base? An acid after donating proton behaves as a base. Means after loss of this proton, the remaining part is there now, that is behaving like a base. So that part that is behaving like a base, we are calling it a word called as the conjugated base. I hope the point is clear regarding the acids. So once again learn the definition of an acid according to Bronsted. Acid is a substance which has a tendency to donate a proton, or these are called proton donors. So let's switch for bases. What is a base according to Bronsted? The one that is able to accept H plus ion is called as a base. What is according to the definition Bronsted and Lowry? Base is a substance that is having a tendency to accept the H plus ion. We know ammonia, NH3. It is when treated by the H plus ion that is produced by the acid, it is accepting the H plus ion to form the NH4 plus ion. What is NH4 plus ion? Ammonium ion. What do we call this as the ammonium ion? Whereas NH3 is called as the ammonia. So the substance that is having a tendency to accept the H plus ion is called as a base. Or we can say these are proton ion acceptors. So can we say this is a base here? Ammonia is a base that is able to accept the H plus ion. But after accepting the H plus ion, it is forming some positively charged species. The formed positively charged species we are calling as a conjugated acid of this base. Now NH4 plus I am calling as a conjugated acid of ammonia. What is a conjugated acid? We have the definition here. A base after accepting the proton behaves as acid. A base after accepting H plus ion base as acid. This is called as the conjugated acid. So the two new words you must not forget. One here is called as conjugated base, which is formed after losing the H proton ion, whereas the conjugated acid is the one that is formed after accepting the H plus ion. Now what is the H2O plus H plus? It is accepting the H plus ion, so we say it is an Bronsted base. The H3O plus is called as the conjugated acid of water. Conjugated acid of water. In the next video, I will give you one table in which we will have the difference between the conjugated acid, the ion that will be formed, and conjugated base that will be formed by some compounds. Learn this concept, children. No doubt. Thank you.